we're going to talk about the graphs of logarithmic functions. Now, I told y'all yesterday, how do we think? How do our brains think? Exponentially, okay? We don't think logarithmically. So the easiest thing to do is, if you're in a log form, to go ahead and change it to exponential and then to solve. And we'll talk about that on your web assignment. But when we graph logs, we're not going to get as in-depth as we did with exponentials. Because you guys cannot, without a calculator, input an x value to find the y without, or to do it by hand. Like you're not going to be able to do in your head, log base 3 of 7 equals whatever. So what we're going to do is just focus on finding domains and range, vertical asymptotes, and x-intercepts, okay? So what I want you guys to remind yourself, write down please, on your calculator, there's a button that says log. And right above that word log, if you were to hit second and then that button, you would have 10 to the x power. Logs and exponentials are inverses of each other. When we start solving tomorrow, we're going to condense and expand and then solve. When we do that tomorrow, you will see that that's the pre-calc part of this. Solving equations is just like every other equation you've ever solved. You just have to know how to undo. How do you undo multiplication? Division. How do you undo subtraction? Addition. How do you undo exponential? You take the log. All right. Then there's another button on your calculator that says ln. And on top of ln, if you were to hit second, it's e to the x. ln is a specific kind of logarithm. It's called the natural logarithm. E to the x is that specific exponential. Remember we talked about that? It's already programmed in your calculator. So when you hit E, there's already a value, similar to like when you hit pi, there's already a value programmed into your calculator. But what I want you guys to take from today, when we talked about our exponential function, all right, let's just do a little quick review. Exponentials. All right, our domain for our exponentials was what? Negative infinity to positive infinity. Our range was based upon our horizontal asymptote, correct? Agreed? And we found the y-intercept. All right, you guys just did it on your quiz. You did it on WebAssign. When we talk about the inverse function, which is a log, or ln, logarithmic, the domain is not negative infinity, positive infinity. The range is. We're not finding the horizontal asymptote. We're finding the vertical. That is what is going to be, or to determine our domain. And then we're not going to find the y-intercept. What do you think we're going to find? The x-intercept. There will not be a horizontal. So if you guys notice, right? Look at these two charts here. I have 2 to the x power, and I have log 2 of x. Those two are what of each other? They're inverses. Yep, they're inverses of each other. What do you notice happens to your x values and your y values when you switch from one to the other and back? What happens with the x and exponentials? Where does it go in a logarithmic? To where? Look at your x values in exponential compared to your y values in the logarithmic. Are they the same? Look at your y values in your exponential as opposed to your x values in your logarithmic. What happens to your x and y values when you switch from one function to the other? They switch because they're inverses of each other. Yeah, that's fine. I mean, we'll go over the rest of them today if you have questions. All right, so let's move along here and just talk about what our graphs look like, okay? If you have an exponential function, all right, our exponential functions are in blue here. You guys see that? And then do you see your logarithmic function in red? What did they do? They flipped, okay? They flipped. Their x values and their y values flipped. I'm going to go to the next slide here in a second and talk to you about our different characteristics and stuff like that. But I want you to understand, this is probably the most important slide on this PowerPoint. When you are talking about a logarithmic function, it reverses the domain and range of the exponential. They are inverses of each other. That is going to be paramount that you guys remember that and understand that for the next few days. Something else that's very important to remember, the range for our logarithmic function is negative infinity, positive infinity, always. Your domain is what's going to change, and it's going to shift. Your domain will shift with your horizontal shifts. How do we shift horizontally? What does that mean? It goes which direction? Which direction, Alec, if we shift horizontally? Left and right, good. When you talk about the vertical asymptote, how do we find the vertical asymptote? By doing what? Setting the parenthesis equal to 0, good. And then we're going to find the x-intercept by plugging in 0 for what letter? Y. Okay, now when we talk about domain, in our exponentials, when we talked about range, remember it was either our range was negative infinity to the horizontal asymptote, or the horizontal asymptote to positive infinity, correct? It was either the bottom or the top. So we're going to look at this the same way for domain, but instead of bottom to top, we're going to look left to right. So your domain is going to be one of two things. You're either going to have a domain that is negative infinity to the vertical asymptote, or it's going to be the vertical asymptote to infinity. Because how do we read a graph? How do you read a book? Left to right. Now let's think about this, all right? You're going to be able to tell the domain without doing anything. And I'll show you in just 1 second how you're going to be able to do that. Okay, all of our transformations still occur. If there's a plus or a minus at the very back or stuck up in the front, but you're adding or subtracting to the function itself, it's moving up and down. If you have something adding or subtracting inside the parentheses, that's going to move us left and right. This is a big thing right here if we are going to be able to tell our domain. Because where does this, with a negative out in front, that flips over what axis? The x-axis. So it goes from top to bottom. All right, but if we're looking left to right, where does a negative inside with my x flip? It flips it over y. So it flips it from left to what? To right. So think about it, guys. If you have a negative, say I have negative x plus whatever, a number. It's going to shift your graph to it's going to flip it from one side of the x-axis to the other. So your domain in this case would be negative infinity to your vertical asymptote. If you have a positive x minus or plus a number, your domain is going to be from the vertical asymptote to infinity. Remember when we had a parabola, if there was a negative out in front, you knew it was from negative infinity to the vertical? And then if it was positive, it would be from vertical up. Same exact thing, but we're not looking for a negative out in front. We're looking for a negative inside the parenthesis. It's going to be really important for you guys to see. We're going to do a couple examples, so just relax. Just relax. But again, we're going to be really, really basic with our graphing. We're not going to get too detailed. I think there's one question on your test about this. It's nothing super duper. So you're going to have a question like this. Okay, first of all, are we in logarithmic or are we in exponential? Logarithmic. How do you know? Because it says log. Okay, so I'm going to write the problem right here. Make sure I write it correctly. Negative log base 3 of x minus 1 equals y. Yeah, I know. I took out the graphing one. Yeah, just go ahead and skip it. You can write it y equals. It's fine. I like to write it like this. So we're going to find all the stuff. We're going to find the domain, the range. We'll talk about vertical and horizontal asymptotes here in a second. And we're going to find the x-intercept. There's two things right now that you can answer with 100% certainty. What are those two things? The range is negative infinity to positive infinity. And what else do you know? There's no what? No horizontal asymptote. Good. So we're going to find the other stuff. Now, when I find my domain, similar to our rational functions, guys, didn't vertical asymptotes and domain go hand in hand? Same thing. How do you find the vertical asymptote? You set what? The parenthesis equal to what? Whatever's in the parentheses, set equal to 0. So I have x minus 1 equals 0. What do I do to both sides? X equals 1, yeah? Add 1 to both sides. So my vertical asymptote is at x equals positive 1. So I'm going to come over here to positive 1. And I'm going to write my vertical asymptote. That means my graph gets really close to that, but does not what? Doesn't touch it. So now our graph is either going to exist from negative infinity to the vertical asymptote, or from the vertical asymptote to positive infinity. It's either on the left side of that or the right side. Our exponentials, it was above or below. Now it's going to be left or right. You can already tell me whether it's going to be negative infinity to 1 or 1 to infinity. Is this positive or negative? Not the negative out in front. Inside. Is that positive or negative? Positive. So you know that your domain is going to be from the asymptote to infinity on the right-hand side. Now, again, if you don't see that, you're like, what? That's okay. Watch. I'll show you how you can get it right. All right, so the last thing we're going to do is we are going to find the x-intercept. But what are we plugging in for y for finding the x-intercept? So I have negative log 3 of x minus 1 equals 0. Now, we're going to find a different way to do this over the next few days. But I'm going to show you how you guys know how to do it right now. How do our brains work? Exponentially. So I'm going to go ahead and rewrite this. I'm going to go from logarithmic to exponential. So the first thing I do if I'm going to go from log to exponential is cross off that log, right? So what is my big base going to become? Negative 3. Everybody with me? So once we make our little number, the big one, what happens to this piece and this piece? They do what? They switch. So negative 3 to the 0 power equals what? X minus 1. Perfect. And now we can solve this because negative 3 to the 0 power is what number? 1 equals x minus 1. And then what do? I'm going to add 1 to both sides. So my x-intercept is where? At 2. So I would write it as 2, 0. Now, I'm not going to be super specific with how you guys graph this because we're doing it by hand. What I need to see is that you have the vertical asymptote in the right spot, that you have the x-intercept in the right spot, and that when you draw your graph, it does not what? It does not touch. So this would normally, don't copy this for a second, this would normally come like this and go like that. Now, since it's reflected over the x, it actually looks like this. Comes like. But again, I'm not super concerned about the direction. What I'm concerned about is that you have your vertical asymptote in the right spot, your x-intercept's in the right spot, your domain is correct, your range is correct, and that you do not touch the vertical asymptote. All right? That's the main pieces that you guys need. Does that make sense? All right, let's look at the next one. I changed it, so go ahead and change it. All right, we're going to find the domain, x-intercept. We're going to find all the stuff. But change yours to log 4 of negative 2x plus 9. So I'm going to say, okay, we're going to find the domain, range, vertical asymptote, horizontal asymptote, and x-intercept. Sometimes there's a y-intercept, sometimes there's not, but you guys aren't going to find it. All right, what can I answer straight away? Range is, so negative infinity to positive infinity, good. What else do I know? Is none, good. So domain and vertical asymptote are going to go hand in hand. Once you find vertical asymptote, you can answer domain or you can wait until you graph it. But how do I find the vertical asymptote? Parenthesis equal to 0. So I have negative 2x, did I change it to plus 9, equals 0, okay? So negative 2x equals negative 9, agreed? Divide both sides by negative 2. What does x equal? 9 halves. Where is that about? Well, 2 goes into 9 how many times? 4, so about 4.5. Just for your mind, so you know where to put it on the graph. All right, so I know that my vertical asymptote is at x equals 9 over 2. You can leave it as 9 over 2. What is my domain? Negative infinity to 9 over 2. How did Chris know it was on that side? Because there's a negative right there. Good. Now, if you didn't see it or you're confused, you're like, oh, I still, that's fine. Don't worry about it. Let's go to 9 over 2. Remember we said it's like in between 4 and 5, right? Does it have to be perfect? No, but it does need to be in between 4 and 5. Okay, there's my vertical asymptote. Now let's find our x-intercept. How do you find the x-intercept? You plug in 0, 4. Okay, so I'm going to go ahead and write log little 4 negative 2x plus 9 equals 0. How do we think? Exponentially. So I'm going to cross off my log and write a big what number? 4. Get in the habit of writing big. You'll see why over the next few days. But what happens with 0 and negative 2x plus 9? So this comes up here, and this goes here. What is 4 to the 0 power? 1 equals negative 2x plus 9. So now what? Okay, subtract 9. So negative 2x equals negative 8. Divide both sides by negative 2. What's x equal? Okay, so how would you write your x-intercept? 4, comma, 0. Perfect. So I'm going to come over here to 4. Now, does it make sense with what we found our domain to be that my vertical asymptote is at 9 over 2 and my x-intercept is to the left of it? It sure does. So how am I going to draw this? You guys just get a nice little curvy thing right here. Get close to the x. The vertical asymptote should say, I'm sorry. Just don't touch it.
For the x-intercept, can we just set it equal to 1? Because anything, the 0 is always going to flip. You can just, we don't have to do that first.
God bless you. No, because you know it's going to happen. I mean, I just get in the habit because it's easy. When we get to solving, you're going to want to think exponentially. That's why we're doing it. But yeah, it's good that you recognize that that's happening. All right, let's scoot a little bit. Now we're going to talk about the natural log. Guys, natural logs and logs. Same concept. The natural log is just the inverse of the specific e to the x. It's the same button on your calculator, e to the x and ln. Right? It goes hand in hand with log and exponential 10 to the x. But all of the characteristics of a natural log has the exact same characteristics of our regular log. So let's go do an example here. Is this still a logarithmic function? Yes. What kind of a log function is it? It's a natural one. Okay, big deal. It's the same exact thing. We're going to find the domain, range, vertical asymptote, horizontal asymptote, and x-intercept. Find all of that stuff. What do you know right away?
The range
Is perfect and is good. Remember, domain and vertical go together. So how do you find parentheses equal to 0? X minus 3 equals 0. So x equals, so your vertical asymptote is at x equals 3. So go over here to 3. Good. What's my domain going to be? 3 to infinity. How'd you guys know that? Because it's the positive x inside. Good. And then we're going to go one step further, and we're going to find, so ln x minus 3 equals 0. What is the inverse? What's the opposite of ln? E, right? Right? So instead of crossing off ln and writing a number, I'm going to cross off ln and write its inverse, write its opposite. Log base 4, its inverse is a big base 4 and have an exponential. So what happens here with x minus 3 and 0? They switch spots. Good. The math should still math, guys. What's e to the 0 power? 1 equals x minus 3. Now what? Add 3 to both sides. And x equals 4. So how would you write your x-intercept? 4, comma, 0. Perfect. So I'm going to come over here to 4. Write my intercept. Does that make sense? Go back to your domain. Just to make sure. Does it make sense that your x-intercept is on the right-hand side of your vertical asymptote? Yes. So then just go ahead and draw a little sketch. Tamara, do you have a question, babe? Okay. So now look, when you guys get to WebAssign, and some of you are going to look at this, there's a question. I think one of them says like e to the ln 4 equals 4. Right? Is that true? That's a true statement. So then down here it says e to the 4 equals, and you have an answer box. And literally what they want you to type in is e to the 4th. Right? There's some it says like e to the ln 5. Simplify it. What is that? It's just 5, right? The first 3.2a is just going over those properties of the logs. Going from exponential to logarithmic, vice versa. If you guys have, look, ln of 7 equals ln of x plus 2. What can you do to both sides? Why can you cancel off the ln's? Because there's just one on one side, one on the other, and then you set that equal to each other and solve.
What if it's like 7 ln to the 7th?
7 ln to the 7th, like that?
No, like the ln's big and then the 7th.
So it won't. Do you have one like that?
I think it's like 7 at the bottom. It's weird.
Okay, just show it to me.
Okay.
Because, I mean, it could be like this. That should say log, not larog. Sorry. Correct. Mm-hmm. It's one of those property ones. Let me see. Okay, so hold on.